Hey everyone, and thanks for tuning in again. In today's video, we'll be covering an introduction to GPower 3, a free software program for power analyses. So remember that power is the probability of rejecting the null hypothesis when the null hypothesis is false. In other words, correctly rejecting the null hypothesis. So in this video, I'll be going over how to download and install GPower 3, which again is free. We'll revisit some factors that affect power, including alpha, the true alternative hypothesis, and sample size. And then we'll get into the actual examples of power analyses. First, we'll be covering some for the t-test family. So this involves just regular t-tests, in addition to t-tests for regression coefficients. And we'll also look at an example for the f-test family. So for your traditional or common ANOVA. Alright, so with that, let's go ahead and get into the lab. Alright, so to start, what we're going to do is we're going to download and install the GPower. So this is the website here. It's a German website. It's the psychology department for the researchers that develop the software. This is really long and in German, so I'll try to remember to put this in the description of the video. So if you go to the description of this video, you'll find this link there, and then you could follow it and then follow along from this web page. Alright, so as you can see, GPower here is highlighted because this link takes you straight to the GPower page. It has some information here about registering, and then some really useful help files here. So this is the GPower manual. It goes over in a lot of detail how to best use GPower and how to use it for different reasons that go beyond this particular lab here. So if there's anything that you need to do that has to do with power analysis, and if GPower can do it, you'll find it here in this manual. And then here's a short tutorial of GPower written by some of the people who developed the software. So if you follow this, this will teach you again in more depth how to use GPower. So again, just some very helpful files here. And then here are the references for the software. So for here you could download the PDFs, and I'll show you an example. So this first one right here, so these are actual papers that have been published. This one has been published in Behavior Research Methods that gives a description and shows applications of GPower. Okay, so I'm going to exit out of this. Alright, so let's get to downloading. When you go down here, you'll see there's this download section. Just to reiterate, GPower is free. However, commercial distribution is strictly prohibited. And then here's some more details about the terms of use. And then finally, highlighted here, we have the link for Windows and then the link for Mac. So I'm going to go ahead and go through Windows since that's the operating system that I have. So I'll go ahead and click on this. And then you can pick the folder that it'll download in. I downloaded this previously, so if I go to my file finder and go to downloads, that's where I put all of my downloads from online. You can see here I have the GPower Win underscore 3.1.9.7. And so it's a zipped folder, so you'll need to extract the contents. So for PC, you just click on Compress Folder Tools, and then you can click Extract All. This pop-up will show up. It'll ask you where you want the files to be extracted. I want them to be extracted in the same location. So just go ahead and extract. And then if I exit out, or if I maximize this window here, here are the contents of the GPower folder. So there's a Word README file, which is very useful. Let me go ahead and open that up real quick and show you what's in there. Alright, so here's some agreement stuff. Here is the paper that they ask you to cite if you were using this in your own research, and then some registration information. Okay, so that's pretty straightforward. And then here, there's a text document called installation. And so if we look at this, this is just installation instructions. So if you follow these instructions, at the end of it, you should have GPower installed onto your machine. So first is to run the setup, and then just follow all of the instructions once you open up that file. So if you're installing GPower for the first time, the setup file is right here. You would just double click that and then just follow the instructions, and then at the end of it, you'll have GPower downloaded onto your machine. All right. So let's assume that we have GPower now. So if I go into my programs here, I'll just go down to G, and then I'll go ahead and open up GPower 3.1. All right, so while that's loading up, remember that there are 3 factors that affect power. So there's alpha, which is the probability of a type 1 error, and we usually hold this at 0.05. So typically we don't change this value, it's always 0.05. The second factor is the true alternative hypothesis. Typically we talk about this in terms of effect sizes, which is the difference between population means in standardized units. Most commonly, you'll hear this referred to as Cohen's d, where a small effect is equal to 0.2, a medium effect is equal to 0.5, and a large effect is equal to 0.8. And then finally, there's sample size. So we have alpha, effect size, and sample size. Those are the 3 things that we're going to focus on, and the 3 things that we have to know to be able to compute power. All right, so let's go ahead and get started with our first example. I'm going to go ahead and start with just a regular t-test. So here we pick the family. All right, I'll put it here. Here is the test family, and then we have the statistical test, and then here we have the type of power analysis. Now there are many options in these drop-downs. I'm only going to go through 3 examples. So let's start with the t-test family. And then I want to, typically we're looking at the difference between 2 independent means. You can also look at dependent means here, but we'll look at the difference between 2 independent groups. And then when we want type of power analysis, typically we're interested in the required sample size. So I'm going to choose here, a priori, compute required sample size. But as you can see here, you can compute implied alpha and power, you can compute required alpha, you can compute achieved power, and then you can also compute the required effect size. But most typically, especially when you're writing grants and trying to get money from the government, they're going to ask that you show that you have the sufficient sample size to detect the effect if it exists in the population that you're studying. All right. So again, we'll click here on a priori. We want to compute the required sample size. So here, we have to give alpha, power, and effect size. So for tails, we're going to choose 2, because no one really ever does 1. Unless your particular field uses 1, then you can change that to 1. And then for the effect size, let's say we're interested in a medium effect. So that's 0.5. That's good. And then alpha, it's going to be 0.05. And then power, we're going to change this to 0.8, which is typically the desired power in psychology. And then here's the allocation ratio. So the sample size of the first group compared to the sample size of the second group. So n2 divided by n1. So let's say we have equal sample sizes. So that'll be 1. And then we can calculate the sample size. So here we have all of this information here, like the non-centrality parameter, critical T, degrees of freedom, sample size of group 1, and sample size of group 2. So since we're specifying that sample sizes are equal, our total sample size is 128, which breaks down into 64 for group 1 and 64 for group 2. And then here is what the actual power is. So 0.80 and then all these other decimals here. So here, given that we're expecting the effect size to be around 0.5, which is medium, and that we have the typical alpha for psychology research and the typical desired power for psychology research, and that we are going to collect sample sizes in both groups that are equal to each other, we need a total sample size of 128 with 64 in each group. Okay, and then here we have our central and non-central distribution. So remember that the central distribution describes how a test statistic is distributed when the difference tested is null. So this is when the null hypothesis is true, and so that's why it's centered around 0. And then in blue, the dotted line, we have our non-central distribution, which describes the distribution of a test statistic when the null hypothesis is false. All right, so that's the first example. Now let's compute the required sample size for a t-test of a regression coefficient. So here, let's go to linear bivariate regression, and let's say we have one group and we want to test the size of the slope. So remember that the t-test for the slope is testing whether the slope is different from 0. Okay, and then again, we want to compute the required sample size. So we're going to do a two-tailed test. Let's say that our slope, I'm just going to pick an arbitrary slope here, but let's say we expect the slope to be 0.3. So for every unit change in x, y is expected to change 0.3 units. The error probability, again, alpha will stay at 0.05, and then here for power, we'll change that to 0.8. The null, the slope of h0, again, is 0. If there's no relationship between x and y. And then here, we kind of have to make guesses about what the standard deviation of x and y are going to be. So that will be largely based on your area of study and the pre-existing literature on whatever effect that you're studying. So here I'm just going to say that, let's just say our variables are standardized, hypothetically. So the standard deviation will be 1 for x, and the standard deviation will be 1 for y. I can go ahead and calculate. Again, we get all of this information, but what I care about here is the total sample size. So the required sample size to successfully detect an effect, if it exists, is 82, given these parameters here that I've entered in on the left side, the input parameters. Okay, so again, for a slope of 0.3 with alpha equals 0.05, power of 0.8, and then these standard deviations for our x and y, the required sample size is 82. Okay. And then the last example, we'll do one for the F-test family, and we'll look at an ANOVA. We'll look at the omnibus test for a one-way ANOVA. So we have one factor, and then again we're going to compute the required sample size here. So let's say our effect size here, we'll use the default here, is 0.25. And then Alpha again will stay at 0.05, and then power again will change to 0.8. And then let's say we're comparing 3 different groups. So if there's a difference between the groups, what is the sample size that we'll need to detect that difference? All right, so again, total sample size, here we have 159. That is the required sample size to detect an effect if the effect exists. And then, as you can see here, we have the central distribution for the F, which it looks a little bit different than the T distribution, obviously because it's more of like a positively skewed distribution. So, and then we have the non-central distribution here, which is the blue dotted line. All right, so again, we went over how to download and install GPower. We revisited the factors affecting power, which here, when using the software, we had to specify alpha, the true alternative hypothesis, which typically is effect size, and then also we also had to specify power, and then we would get the sample size needed. So we kind of flipped it a little bit there. And then we covered some examples, including the t-test family, where we looked at an independent samples t-test, and a t-test for a regression coefficient for the slope of the regression. And then we also looked at an analysis for the f-test family, looking at a one-way ANOVA. And so with that concludes this lab on an introduction to GPower 3.